Welcome, everyone. Thank you for taking the time to join us today. Uh, I'm Ashish Das, and probably you remember me over last few webinars. Currently, I work as an IT solution architect with more than a decade of experience in IT software and solution. Like most others, I also possess a passion to solve real-world problems with the help of technology. Uh, yeah, over the past few sessions, our team has conducted webinars mostly on building understanding on cloud platform, predominantly Google Cloud Platform and related services, and also on understanding on topics such as simplifying microservice architecture by using Istio service mesh, on Envoy proxy, etc. I wish to deep dive on one of the use case of the Istio service mesh and the features it brings to the table. uh, we will have a few demo probably may not be in today's session, but yeah, in this journey over the next couple of sessions. So today's session will be kind of an introductory session, and next 20 to 30 minutes we're gonna learn and understand about Istio service mesh and the few buzzwords related to that. Yeah. Uh, so these are the agenda for our today's session. So we'll cover how what are the challenges of large scale multi-cloud applications, how the Istio service mesh can really help, uh, what is the component of Istio service mesh, what are the advantages of the Istio service mesh, and we'll just a little bit discuss about how this authentication works using the OAuth 2 flow, yeah, in Istio service mesh. Okay, so I'm sure all of you have ever tried booking a ride in Uber, right? It feels pretty easy, isn't it? However, have you ever thought that how difficult and how all these different function inside the Uber app works so synchronously? Yeah. So, but the actual architecture, end-to-end architecture may look quite complex. But here I have just tried to depict different web services and how the traffic goes yeah, from one web service to another. Even if it looks simpler, in practical scenario it is actually quite complex. There are multiple reasons for the complexity. Since one microservice has the possibility of multiple version. It can different microservices can run on different cloud. Yeah, it can be part of multiple cluster. Somebody has not updated his app, but the services cannot be outraged for that particular region. Yes, for few features may not be available for that, but the entire services cannot be outraged. And if any call between any two services giving some problem, it is a really cumbersome activity for someone to debug and find the root cause, right? uh, yeah, so remember we discussed earlier one of the use case of the local travel company named Rambabu Travel. Yeah, their team also faced similar challenge. So what are the challenges? Because those challenges are okay. I'll just tell about a little bit about the that local company. So uh, one part of their company operates on a fleet vehicles that transport customer to and from airports, hotels, and other destination. The company's fleet management system is those are built using microservices architecture, with each service handling a different aspect of the fleet management process, such as your vehicle scheduling, driver assignment, payment, trip management, notification, vehicle maintenance, etc. However, as the company grows and the number of services increases, they begin to encounter problems with service to service communication. So each service needs to know if the location and the availability of the other service it communicates with, right? And it needs to handle issues such as load balancing, service discovery, etc. And obviously, it needs to retries on its own. So all these problems lead to a lot of complexity and make it more difficult to add new services at a scale. And even if you want to change the existing one, that is also the managing individual services is a difficult, very frustrating activity. So in addition, if the services goes down or become unavailable, uh, it will it can cause problems for the entire fleet management system, isn't it? Because if one communication goes out, then it will disrupt the entire vehicle schedules and causing delays for the customer. So to solve this problem, we advise to implement a service mesh. So they can install an open source service mesh such as uh, maybe Istio or Linkerd. Okay, anyway, so Istio, so which provides a basically a layer of abstraction between the microservices and the network. And with the service mesh in place, each microservices no longer need to handle the service discovery, load balancing, etc. Instead, these tasks are handled by the service mesh, which also provide features such as traffic management, security, observability, etc. For an example, if the vehicle scheduling service needs to communicate with the driver assignment service, or here in this case, the driver management service and passenger management service, if both these service need to communicate each other, it simply needs to send to the local proxy provided by the service mesh, which then routes the request to the appropriate destination based on the routing rules that can be configured. And if the driver assignment service is unavailable, the service mesh will automatically retry the request to route the backup service. So by using this service mesh, the team could able to reduce the complexity of basically on their microservice communication, improve the reliability, scalability, and adds new features as well, like A/B testing or canary releases, etc. Yeah. Uh, so basically, if you want to jot down the challenges of this large and distributed system, so these are basically comes down like data is spread across the cloud and across the cluster. So the perimeter security, like firewalls, those are not enough, and the network policies, those are defined. Those are basically local to the clusters, and those does not work seamless for multi-cluster. Management of this management of the security and network is often developed local to each microservices, and it looks complicated. Similarly, development team those has I mean though developed developing routing logic and security logic, that obviously for when we say about 500 1000 or 5000 microservices, so for developing each and every uh, routing logic and security logic for individual microservices creates frustration and burnout as well in the development team. Yeah, so all these problems can be overcome by using service mesh. So what exactly is service mesh? Uh, yeah, let's say we are implementing a microservice architecture using Kubernetes or any other container. Yeah. So there are a lot of common features that are present across different microservices. So as you discussed, security, matrices, logging, tracing, or release management, all this. So we don't want to implement all these features in each of the individual services, because if you want to implement them individually for a service, uh, we will face scalability issue, and also it will increase the effort and complexity within the microservice. So how do we implement them in common? That is where this Istio service mesh is very useful. Yeah. So Istio is basically one of the most popular service mesh implementation. Uh, okay, so okay, there are other service mesh also available in the market, but yeah, let's quickly overview how this Istio service mesh is typically work and how it is typically implemented. Yeah, let's say we have two microservices, services A and services B. Yeah, and I would want to implement a service mesh pattern. So what we do actually will deploy a container. There is an additional container that is known as a proxy container along with each of the microservices. Okay, so the Kubernetes pod basically that contains this service A will also contain the container of this additional proxy. Yeah, the same goes with the services B as well. Correct. So we have a proxy container which is deployed with each and every pod of the microservices. proxy deployed beside each container, and this container is basically uh, created by Istio by something called Envoy proxy. I'm sure there have been previous sessions, introductory session on Envoy as well by our team. Maybe you can check those videos as well. But this Envoy proxy intercepts all communication that is going in and going out of each and every microservices. Yeah. So that is why this would be one of the best place to implement this common microservices features. Okay. So in addition to this data plane, there is something also there as known as the control plane. This is called as Istio control plane. So why this is there? Why how do you think this proxy will come and attach to a container magically? So we need something to inject the proxy in, isn't it? So that is where this control plane becomes very important. So it used to manage and configure the proxies. We can also configure the certificates for our proxies, and it also provides features such as service discovery and others. Obviously, we'll look that in a while for these microservices. So as of now, this architecture of implementing an Istio service mesh is the most stable and been adopted by multiple organization. Yeah, so there are other service mesh as well in the industry, as we mentioned, so such as Anthos service mesh by Google Cloud Platform or Anypoint service mesh by MuleSoft, so etc. Yeah. So basically, what we learned is when you want to implement common features across microservices, we can go for a service mesh. And when we are using a service mesh, we may have a this sidecar proxy, which is an additional container and is deployed beside every microservices. And the control plane control the sidecars and also provide a number of other features. So this service mesh is an infrastructure layer that abstracts the network and the communication complexity of microservices based application. It provides the dedicated communication channel for microservices, and helps in managing the traffic, security, observability of these services. Yeah. So the core idea behind implementing a service mesh is to move the network communication related responsibilities from individual services to a dedicated infrastructure layer. Yeah. So this infrastructure layer consists of set of proxies that is deployed alongside the microservices. Correct? Okay. So now uh, let's talk about the different components of the Istio. Okay, Istio is nothing but an open source service mesh architecture. So that provides a set of tools to manage microservices based application. It is built on top of the Envoy proxy that provides additional features, right? So majorly we have there are a few components of Istio. So one is data plane, control plane, service mesh interface. Data plane is the layer. So this layer, we can say this is the data plane. Data plane is the layer responsible for handling the actual data traffic between the microservices. It consists of set of Envoy proxies that are deployed alongside the microservices. Yeah. Uh, and then what is a control plane? Control plane is, we can see this particular thing. So control plane is a layer responsible for managing these Envoy proxies. Yeah. So those are deployed in the data plane. It consists of set of control plane components responsive for configuring, monitoring, and managing different proxies. Similarly, service mesh interface, obviously we haven't shown here. So service mesh interface is a set of APIs and the specifications that define the interaction between the data plane and control plane. It provides a standard way of implementing a service mesh architecture. There are other components as well, which are service registry. Service registry is nothing but a database that keeps track of all the microservice registered with the service mesh architecture. It is also responsible for providing a dynamic list of available microservices to the proxies. Those are deployed in the data plane. Okay. Uh, Earlier, like in the earlier version of the Istio release, so there were individual components, and so all these components which are now those are part of Istio control plane known as Istio D. Yeah, so we there were components like Pilot, Citadel, Galley, gateway, etc. So those everything is part of now Istio D. But anyway, the work for that, okay, I'll just touch on that. Istio Pilot is basically a control plane component of Istio that manages and configures the Envoy proxies. Yeah. So yeah, so Istio Pilot provides a global view of the entire service mesh, and it ensures that all the Envoy instances have the latest configuration. This is what the pilot does. Now, what Citadel do? Citadel is the identity and certificate management component of Istio. It provides the strong authentication and authorization for services, and it generates and distributes the certificates. And what is Gale? Gale provides the configuration management service for Istio. Yeah. Similarly, there is also one component called Istio Gateway. So gateway is basically enables external traffic to enter the service mesh. It also provides the load balancing, TLS termination, and other features like securely exposing the services to the external clients, etc. Yeah, there was also the or I mean in the previous version of Istio, there were components such as Istio Mixer and Istio Telemetry. So Mixer is basically another tool, another control plane component that enforces the access, control, and usage policies across the service mesh. And it collects the telemetry data from Envoy proxies and other sources and generates reports and alerts. And what is telemetry? Telemetry is a set of components that collects and aggregates matrices, traces, logs from these Envoy proxies and other sources. Yeah, it provides the powerful observability and troubleshooting capabilities for the service mesh. Anyway, so all these components are now part of STOD, so we don't have to like install each and every component individually. We only need to there are certain set of commands that will only once the Istio-D is installed, then yeah, that is fine. So yeah, we'll have a demo probably in our next session. So how we're gonna install Istio and how this work in a distributed framework having a lot of microservices. Yeah. Yeah. So yeah, one more point I want to add. So this Istio provides a data layer based on the foundation of network proxy instances derived from this Envoy proxy. Yeah. So Envoy is basically nothing but L4 and L7 proxy, that is responsible for all the service interaction in Kubernetes and the virtual machines. So now we can say what is L4 and L7 proxies. So L4 and L7 is nothing but a networking terms. So which basically denotes to the different layers of the OSI model. If you know that in networking we learned the concept of OSI model. So a proxy is a network device that acts as an intermediary between the client and the server, right? And L4 and L7 proxies, they differ in their functionality and the type of the traffic they handle. So uh, L4 proxy operates at the transport layer, which is also known as layer 4 in the OSI model, which means it works with the TCP and UDP protocols. Yeah. Uh, L4 proxy uses the network address translation. So this is the NAT to route the traffic between client and service. And obviously we can configure to I mean, to perform the load balancing, distribute the traffic among multiple servers based on the simple rules such as round robin or least connection, etc. So L4 proxies do not have the knowledge of the application layer, and it cannot inspect or modify any of the application data. So for that purpose, we have L7 proxy. So what is an L7 proxy? So L7 proxy operates at the application layer, which is the layer 7 of the OSI model. So which means it works on the protocol such as HTTP, HTTPS, or SMTP. Yeah. So L7 proxies, it can inspect application data and make decisions based on the content of the traffic. For an example, L7 proxy can route traffic based on the URL path or header information in an HTTP request. So L7 proxies can also perform advanced functions such as content caching, SSL offloading, even web application firewall protection also it can perform. Yeah. So overall, L4 proxies are more of a network level function for such as load balancing, routing, and L7 proxies provide more of an advanced application level feature. Depending on the need of the application, we may choose to use L4 and L7 proxies or combine both in our Envoy. Yeah. Uh, okay. So Envoy can be configured on to enforce the authentication and authorization policies on incoming requests. So okay, let's discuss about the authentication authorization, how it works in Istio. Uh, Okay, firstly, let's start with the definition. Authentication stands for, it's a process of verifying the identity of a user or a service. Okay, and authorization is the process of determining what action a user or service is allowed to perform in my network or in my application. Correct. And what is this OAuth 2? OAuth 2 is an authorization framework that allows user to grant access to their resources to third-party applications without giving them the password. Okay, and obviously this OAuth 2 is a very popular technology right now. It is used by many of the popular application and services, even in Facebook, Google, or Twitter. Yeah, and OIDC is the protocol that is built on top of this OAuth 2 and that add authentication capabilities. Okay, so it provides a basically a secure and standardized way to authenticate users across multiple applications. So Istio supports OIDC for authentication and integrates with various OIDC providers such as your Google or Microsoft or even Okta. Okta is also an identity provider. Yeah. It is used to authenticate users and provide them with the identity, and that can be shared across the multiple application. Okay, let's understand this flow, how this OAuth 2 and OIDC flow happens in the Istio. So when a user tries to access a particular service, the request is intercepted by our Envoy. Okay, so Envoy then sends the request to the OAuth provider proxy. OAuth 2 provider asking for the access token. So OAuth 2.0 proxy, it will then ask for the will connect to the identity provider and it will verify the user's identity and generates the access token. So which is again sent back to the Envoy. Okay, so Envoy then uses this access token, uh, some sort of number or something, some sort of token we can think of, we can configure of, and these access token can be used by Envoy to authenticate the user and authorize the request. So if the access token is valid and the user is authorized, the request will be allowed to process. Otherwise, the request is blocked and the user is redirected to the login page. Yeah, sometimes also we can configure how much time this access token can be valid. Like for, let's suppose we have login for 10 minutes, and if after 10 minutes of inactivity, the access token will be invalid. Such kind of things. Obviously, when you're a part of in any web page, secure web page. So yeah, that is how those are being configured. Yeah, so with this Istio's authentication and authorization features, so we can protect our microservice based application from unauthorized access, and we can ensure that only authorized microservices based application from uh, unauthorized access, and then ensure that uh, it can perform certain actions based on our configuration. Yeah, Istio's built-in support for OAuth2 and OIDC makes it really easier to enforce the authentication and authorization policies across our services. Yeah, uh, let's just discuss about the advantages with the Istio service mesh. There are multiple advantages. Okay, so we have jotted on these four based on the experiences. Okay, so one very important point is I mean in terms of advantage, that is traffic management. Okay, so service mesh architecture, so or Istio service mesh architecture helps in managing the traffic between the microservices by providing the features like load balancing, routing, and traffic sifting. Okay, so because we are the traffic are being managed at a common place, so now it is really an advantage for the developer. They don't have to write logic, communication logic, or routing logic, or security logic for individual services. So it will increase the productivity of a developer with network and security abstraction, right? So security service mesh architecture provides the security features like authentication, authorization, or even encryption at the infrastructure layer. So that obviously reduces the complexity of the security for the individual services. Similarly, one more important thing is observability. So which is that is Istio's service mesh architecture provides observability features like matrices, tracing, logging, which help in understanding and the behavior of the microservices. It also support the integration with third-party observable tools like Prometheus or Grafana or Kiali. Yeah, so these are basically the third-party tool that can be very well integrated with Istio, and uh, there can be all graphs or the data being collected. Okay, from I mean via these tools from Envoy, so the graphs can be drawn, and it will definitely it helps a lot to the developing team and operation team. Yeah. Uh, it also provides a 360-degree visibility of the network across the cluster and public cloud. Yeah, sometimes our microservices is actually distributed on multiple clouds. Those can be part of multiple clusters as well for different reason. Okay, so at that time, individual logs at application level, it really doesn't help. So let's suppose we have uh, large volume of microservices and how the communication happens from one to another. And if something goes wrong, how we're gonna debug it? So that's really a nightmare without an 360-degree visibility of network. Yeah. So yeah, with that capability, Istio service mesh really helps for the for her having this 360-degree visibility and then debugging and finding the root cause. Yeah. Similarly, load balancing. Uh, Load balancing is basically it's an features given by Envoy proxy, and that is propagated that is also by Istio, and it provides advanced load balancing features like your weighted routing, circuit breaking. It also support round robin, least connection, and on and random. These rules can be configured. Yeah, so that's it. We can say Istio and Envoy proxy both are open source technologies and have gained popularity in the world of microservice based application. Istio provides a set of tool to manage microservice based application and is built on the top of Envoy proxy. Envoy is a high performance proxy server that provides advanced features such as load balancing, traffic management, observability. Yeah, the key component what we learned is data plane, control plane, service mesh interface. Yeah, control plane is known as Istio. Uh, on we learned also Envoy proxy that is required for managing the traffic between microservices. Yeah, that's it. Probably that's what I wanted to cover as the introductory session to Istio service mesh. In our upcoming session, we'll basically perform a demo where one will how these features works, how we'll gonna install Istio, and how this feature will gonna work. And without Istio service mesh, how the network will look like and how it will gonna help to operation team. Yeah, so those will gonna have the demo. Yeah, so that's it for today's session. Thank you all for joining. If you have any question, you can connect us on contact@ims.ai. Thank you.